Hello and welcome to section 10.3, which has to do with comparing two independent population proportions. Okay, so when we conduct a hypothesis test that compares two independent population proportions, we need to have the following characteristics. The two independent samples have to be simple random samples that are independent. The number of successes is at least 5 and the failures are at least 5 for each of the samples. The population must be at least 10 or 20 times the sample. This keeps the population from being oversampled and causing incorrect results. So comparing two proportions is very common. So if they're different, it might be due to a difference in the populations, or it might be due to chance. So this is how we use a hypothesis test to tell if the difference in the estimated proportions reflects a difference in the population proportion. So the difference of two proportions follows an approximately normal distribution. So generally the null hypothesis states that the two proportions are the same. So what we do is we use a pooled proportion to conduct this test. So luckily for you, you really don't have to, for this course you don't need to know how to do this because we're going to be using the calculator. But here it is for fun, if you want to go over it on your own time, because I know that that's what you do in your spare time is think about statistics. All right, so let's have a super fun example. Two types of medication for hives are being tested to determine if there is a difference in the proportions of adult patient reactions. 20 out of a random sample of 200 adults given medication A still had hives 30 minutes after taking the medication. 12 out of another random sample of 200 adults given medication B still had hives 30 minutes after taking the medication. Let's test at a 1% level of significance. So what kind of test is this? It's a test of two proportions because it asks for a difference in proportions. So what's, the two proportions, piece of A and piece of B. What's the random variable? It's a difference in the estimated proportions, right? Who did not react after 30 minutes to medication A and medication B. So what's the null hypothesis and the alternative? Well, the null would be that they're equal. In other words, that the difference is equal to 0. And because it wants to know if there is a difference, then the alternative hypothesis would be that they're not equal to each other, therefore different. Okay, so let's do the test here. Here we go. So in order to conduct this test, you would have to hit stat, test, to prop z test, and then you hit your successes. 20 for x1. We surveyed 200 total for the first group, and then the second group, the successes were 12, and 200 were surveyed, and then of course we're testing that does not equal. And then you hit calculate, and there it is. And our p-value is 0.14, and our test statistic is 1.47. So if we wanted to draw this thing, we would go back to stat, test, to prop z test, to proportion z test, and then go all the way down and hit draw. And there it is, it's a two-tailed test. Okay, so what kind of distribution was that? We used a normal distribution. And what's the p-value? The p-value was 0.1404. Okay, and here it is. Half of it would be this area and the other half would be the other area. So how did we get this value? We subtract the PA minus PB. PA minus PB, the PA minus PB is equal to 0 goes here. And then PA prime is 0.1 and PB prime is 0.06. So the difference should be 0.04, and it is. And then because it's a two-tailed test, you are going to have the same exact point equidistant from the center, from the mean, or from the whatever the null hypothesis is. Okay, so let's see. Let's compare alpha and the p-value, of course. It was 1% level of significance. The p-value was 0.1404, so p-value is greater than alpha, right? So we do not reject the null hypothesis, or we fail to reject it. So we can say that at 1% level of significance, there is not sufficient evidence to conclude that there's a difference in the proportion of adult patients who did not react 30 minutes after taking medication A and B. All right, so next example. A research study was conducted about gender differences in sexting. The researcher believed that the proportion of girls involved in this is less than the proportion of boys. The data collected in the spring of 2010 among a random sample of middle and high school students in a large school district in the southern United States is summarized in this table. Is the proportion of girls sending sex less than the proportion of boys? What kind of test is this? This is a two population proportion test, right? So we will use PM and PF to describe proportion of males, proportion of females. And then what's the random variable would be prime, the difference. And then of course your null hypothesis would be that they're equal. Your alternative hypothesis would be that the researcher believed that the girls were less involved. So PF less than PM, or the difference has to be less than 0. So that means the test is left-tailed. What kind of distribution is approximately normal? Okay, so let's go ahead and run the test. We do stat test. Two prop z tests, and then for x1 we would enter 156, and then for n1, which is the total, it would be total surveyed, so that would be 2169, and then the other one would be 183, and the total would be 2281. Okay, and then it's less than, and we would hit calculate, and there it is. And we would have our p-value of 0.1045, and it's pretty high p-value. So what if we wanted to graph this? We would go ahead and go back down to 2-prop z test, and instead go to draw. Okay, and there it is. The p-value again was 0.1045. The proportion for females and males was 0.07 and 0.08 respectively. Here it is. So what would we do? We make a decision. P-value is greater than alpha, or alpha is less than p-value, so we do not reject, or we fail to reject. And we'd say at the 1% level of significance from the data, there is not sufficient evidence to conclude that the proportion of girls sending sex is less than the proportion of boys. Okay, and that is it for this section. The homework is 46 through 52, in practice 10.3. Good luck, and I will see you in the next video.